welcome to CB Defense Today, an interview show where we talk about the latest chemical and biological defense technology to aid in warfighter readiness. I'm Jack Bunja, Public Affairs Specialist for the Army's DEVCOM Chemical Biological Center, and my guest this week is an engineer at the center who has been working on autonomous vehicle detection technology which can integrate into existing systems. I'm happy to welcome Mr. Lester Strauch. Lester, thanks for joining me.
Thank you, Jack. It's a pleasure to be here.
Excellent. So let's start off talking a little bit about you. You've been at the center for more than 30 years?
Yeah, this May it'll be 36 years. And, it's funny because all the guys that I work with who are, absolutely brilliant in what they do, they all have their driving factor. And my driving factor is the fact that my dad was a chemical corps officer back in the Korean warfare timeframe.
Wow.
And I actually got to grow up with two of his friends that he made in the chemical corps. I have a really good friend who was in the chemical corps and then he went to tech escort, and also working with David Glynn out at the chemical school. So it's embedded in me to basically protect these warfighters. You get to learn a little bit about what their backgrounds were, what they had to do, and the downfalls and pitfalls that they had from being chemical corps officers back in the day.
So then you took your engineering background.
Yes.
And you applied it to
yes, sir.
To the Army and to chem biodefense.
Absolutely. Absolutely.
Excellent. And currently now you're working with a lot of different detection and autonomous capabilities.
Yes, exactly.
So let's talk a little bit about how the detection system, especially with autonomous vehicles, is advantageous for the warfighter.
So currently, a lot of the threats, you actually have to get into the threat with a detector or get a detector very close to the threat. And that means you're putting warfighters in harm's way. So utilizing autonomy, utilizing robotic systems, now I can pull the warfighters back 5 kilometers and send in robotic systems. And now the robotic systems are in that threat, not the warfighter. So you're saving potential lives by doing this capability with autonomy and with robotic systems.
And so on these robotic systems, you're really working on detection or detectors that integrate with those robotic systems,
correct? Yes. What we try and focus on here at the center is basically how you utilize, how you integrate those systems together. What I would like to see is basically industry producing the best possible robot that's out there, the best possible sensor that's out there. And then our guys get to come together and basically integrate those systems together using common interfaces, using ways to be able to communicate with those sensors and be able to get real-time feedback from those sensors, again, out of harm's way, a distance back from the threat.
Absolutely. Keeping the warfighter safe allows them to maintain being lethal.
Yes, exactly. Exactly.
So, and you're really working on taking a lot of the guesswork out of it for the folks who are deploying the sensors in the field, correct?
Yes, and actually that's one of the reasons why I keep saying, the personnel here at the center are the key. So we're working with groups in research that are able to integrate software technology into our existing things that we are developing and enhance the capability of those sensors. So within Research Directorate, they're working on autonomy, or they're working on artificial intelligence and machine learning to be able to enhance what's coming out of a detector. So not only can you determine, what the threat is, what the level of that threat is, but you can also start to get a percentage of a guess of what it actually is. Okay. So it'll tell you that you're seeing a certain chemical at a certain, I'll say, bar level or concentration, and a probability of like 80% that is actually what it is. And by doing that takes a lot of the guesswork out of knowing what you're reading from a operator's perspective.
Wonderful, and it's keeping those operators able to keep moving on the battlefield.
Exactly.
And not paralysis waiting for...
Yep, exactly what you said. They remain lethal, as a fighter. They get information very quickly, but we're also able to share that information as well. So not only are you looking at it from a tactical operations center close to the threat, but that can be broadcast back to joint operations centers where other people can basically take that data and make decisions.
And allowing readiness to be employed by everyone in the field, right?
Absolutely.
That's amazing. So a program like this is pretty vast, I would imagine. So you have a lot of partners?
Yes, we do. So we started this off from a robotics perspective, working with the Defense Threat Reduction Agency, where they were basically integrating sensors onto robotics platforms. That's when we realized that we could basically build a common interface. So now, as easily as I switch a battery out on a robot, I can switch a sensor out on the robot the same way. So again, maintain that lethality, get the robot out there, be able to do multiple runs with multiple sensors, or put multiple sensors on the robotics platform. So we've been working with the Defense Threat Reduction Agency quite a bit. We've been working with the Joint Program Executive Office for Chem Biodefense, utilizing the sensors that they are developing, also integrating with groups that are integrating robotics, integrating sensors onto robotics platforms as well. So CBurn sensors integrated to robotics platform, or CSERP, that's at the JPO. That's one of the other organizations that we're working with. But we also branch out a lot as well. So we've worked with the EPA, Environmental Protection Agency. We've worked with the National Guard Bureau. We've worked with the Federal Bureau of Investigation, Department of Homeland Security. And the goal is to be able to basically build sensors up that are in a common interface that we can swap amongst other government agencies as well.
That makes it very utilitarian across the board. That's excellent. So what's next? I obviously, a program like this needs different levels. What are your next goals? So
based on what we've been trying to do, linking all these government agencies together, utilizing a lot of the same sensors, the goal is to reach out to industry and start working with industry from a platform and a sensor perspective. As I said earlier, we want to be able to do the integration here at the center where we can put the sensors in the right locations on the platforms to be able to sense properly. But we want to rely on companies that are out there that are building robotics platforms to build the best quadruped, to build the best unmanned aerial system. And the same way goes for sensors, reaching out to companies and being able to access the best sensor that's out there, integrated into our common interface so that we can actually move it around between those robotic systems and basically put that sensor in the best location to give us the best results from those sensors.
And then obviously working to make them smaller, lighter.
Absolutely. It's amazing to understand how grams or ounces of payload on a UAS, basically how that affects flight time. It's pretty astronomical. From a ground perspective, you can handle the extra weight, but even then, if we can get it lighter, it just means more time for those robots to be out in the field.
I'm assuming it impacts battery time and lifetime.
Exactly.
That's amazing. So that's fantastic, and thank you so much for taking the time to sit down and talk with us about it. And please, come back. Maybe we can bring a dog into the studio and we can watch it operate.
Absolutely. I'd love to do that.
Fantastic. Well, again, thanks, Lester, for being here today. And that's it for this episode of CB Defense Today. For the DEVCOM Chemical Biological Center, I'm Jack Bunja.